Alright guys, welcome to the Hoodie tutorial. Right now we are going to talk about the relationship of the power, voltage and resistance and the current. These four are the most important parameters in terms of studying circuits that is under DC circuits that we're going to talk about. So right here we could obviously see colorful and a circle object right here, but this actually explains the relationship of the four parameters. So right now we are going to explain how how do we able to derive a certain equation and how to read this one. Okay, so notice if you can see right here in the in the quarter, in this quarter circle, let's highlight this one by yellow. That's yellow. So this actually represents into the I, which is the current. This is the voltage, this is resistance, and the power. So notice in the circle of this yellow border, this has includes three equations for I. So let's write that right here. I is equals to square root of P all over R. So how did we derive this equation? So if we try to go back to Ohm's law, I is equals to V over R, which is also this one. And and we need try to give the equation of V in terms of P, that would leads to I is equals to, so V from the equation P is equals to VI. If we try to divide both side by I, V voltage would be equal to P over I and then over R. So notice right here, it's also voltage equals to P divided by I. And then I would be equal to, let's write the numerator, and then if we try to raise this one up, that would, we have R, that would become the reciprocal of R. So we have I both side. If we try to multiply both side by I, in the left side, that would become I squared is equals to, and then we can cancel this one, so leaving behind only P over R. And then if we try to find the value of I, we have only just to square both side. This square right here would cancel, leaving behind I is equals to square root of P all over R. So notice we have the same equation or formula right here. So the second one is I is equals to PB. This basically derives from this equation. If we try to divide both sides by V, this would cancel. That would create I is equals to P over V, or the power over voltage. And then this one, I is equals to V over R. That is Ohm's law right here. Okay, so let's go to the voltage. In this another quarter of the circle, let's highlight this by the color red. So this is voltage. Let's focus this one. So voltage is equals to, based on the circle, this is equal to square root of P multiplied by R, or the power multiplied by the resistance. So how did we able to derive this equation? So first things first, we have to go back to Ohm's law. Voltage is equals to I multiplied by the resistance, and then since we already have R right here, we only have to focus on I. So we have P. That's why we have to find the value of I, which has a power on it. So V is equals to, so the only equation that has I and the P is right here. I is equals to P over V. So let's put the value of I, P over V, and then of course the R. So we have V both side. If we try to multiply by V, this thing would have V squared is equals to, this would cancel, leaving behind P R. So if we try to find the value of V, we just have to square both side, and I'll put the square at both side, and then this squared right here would cancel, leaving behind V is equals to square root of P multiplied by R. So notice that we have the same equation. This is how we derive the equation. Another one is V is equals to P over I. That is derived also from right here, from this equation. And then of course V is equals to I times R. This is Ohm's law. Okay, so we are done for the current and voltage. Let's go to the resistance. Right here we have resistance, another quarter of the circle. Let's highlight this by blue right here. So first equation that we can see right here, R is equals to the V over I. So notice this is in the Ohm's law. Another equation right here, we have R is equals to V squared over P. So how did we derive this equation? So first thing, you have to go back to this equation in the Ohm's law. So notice that we have V already right here. So we only have to find the value of I in terms of P. So R would be equals to V. So the value of I which has a P on it is right here, P over V. So I is equals to P over V. Let's put the value of I right here. So R is equals to, if we try to raise this both, that would lead to its reciprocal, V over P, leaving behind R is equals to V squared all over P, which if you can notice, the equation is the same. That's it. So another equation is right here, last equation for R. Wait a moment. So R right here, R is equals to P over I squared. So this is basically derived from the equation P is equals to I squared multiplied by R. So if we try to divide both sides by I squared, this would cancel, so leaving behind P over I squared, which is the value of R. So lastly, we are going down to one parameter, which is the power. Let's highlight this by green. There you go. So first equation, that's P is equals to, let's put it right there, P is equals to V squared over R. So how did we derive this equation? So first things, we have to go back to the basic formula of the power, which is V multiplied by I. So we already have V right here, and the only thing that we need is the value of I, which has in the resistance right here. So P is equals to V. So we all know that I is also equals to V over I. That that's V over R. That would leads to P is equals to V squared over R. So I is equals to V over R right here, multiplied by V. That would lead to P is equals to V squared over R. That is how we derive the equation. So notice that they are both the same. Another equation is P is equals to I squared over R, multiplied by R. So this is basic, as we can see right here. This is the most for me, this is the most familiar power equation. And then another one is P is equals to voltage multiplied by the current of the circuit. Another familiar formula for the power. So that's it, guys. Thank you for watching, and subscribe to the channel for more videos to come, and click the notification bell. So study well, and God bless.